Okay guys, so as I asked you to, I want you to get your notes out from section 8.1 and 8.2 where we were talking about exponential growth and decay. And in sections 8.1 and 8.2, I told you that anything in the form y equals a times b to the x power is exponential. It's exponential because x has a because the exponent is a variable, okay? All right, we also talked about these values here. They tell me some things. This value tells me the y-intercept of the graph, as long as it's in this form. If there's addition or subtraction up here with this x, then it is not the y-intercept, okay? All right, and this value of b tells me if it's growth or decay. Okay, and we looked at the graphs of this function, and I'm going to actually also talk to you about a way to graph if you're not comfortable using the rules today, okay? So let's look at an example. I'd like you to go to the example on the back where it says 3 times 2 to the x. 3 times 2 to the x power. We've already graphed this, okay? I'm going to do it again. First of all, I look at it and it's y equals 3 times 2 to the x. So it is in the form y equals ab to the x power. I know it's an exponential because the variable, the exponent's being raised to is a variable. Okay, so by looking at this, I can tell you that my y-intercept is the point 0, 3. Reminding myself that the y-intercept is where my x value is 0. Why is it 0, 3? Well, if I put in a 0 for x, I get 2 to the 0 power. 2 to the 0 power is the number 1, so this whole thing becomes 1, and then 1 times 3 is 3. And that's how I found my y-intercept. I said that was really important that we had that y-intercept. So if I just wanted to graph this, I could actually just go up to my y-intercept of 3, plot that point. Now, in class we did it with a rule. But to be honest with you, some of these graphs are easy if you just plug in values into a table, any table. All right, how do we do that? You know that with any graph you can plug in x values and solve for the y value. So on these simpler graphs, maybe using the rule for you, it might be easier if you do it like this. So we could plug in the value, one x value to the left of 0 and one x value to the right. All right, I'm just going to pick -1 and 1 for myself. Okay, all right, if I plug in -1, I get 3 times 2 to the -1. 2 to the -1, you have to remember, is 1/2. So I have 3 times 1/2, okay, which means 3/2. It's the same thing as doing the rule, but you're doing it directly using the table. So 3/2. All right, then I plug in 1 into the equation. 1, I let x be 1, so 2 to the 1 is 2, and then 2 times 3 is 6. So I go to my graph and I plot those points, but I really want us to make sure we understand. We are looking at this. This number, 2, is greater than 1. So this is exponential growth. And remember, we talked about exponential growth. It means it's growing from left to right, and it's growing, it gets to a point where it grows really, really fast. All right, so I'm going to plot -1, 3/2 means 1.5, so right about there, and then 1/6. So right about there. Now remember, we said, I'm going to graph it, it's going like that, it's going like that. We said it got really, really close to this line. Okay, it got really, really close to this line, y equals 0. Okay, y equals 0. Got really close to it, but it never touched it. And that was called an asymptote. An asymptote. Okay, so now we've got these places that it can't exist. An asymptote means that this line can never get to it because it doesn't exist there. All right, so y equals 0 is the equation of the asymptote. Okay, so that might be an easier way for some of you. All right, so I had asked you to go to your notes. We're going to try going to the next page. We're going to try, sorry, I'm going to start over. Y equals -3 2 to the x power, okay? All right, so we talked about what I said you should identify what the parent kind of is to this. But we're going to try it the other way. We're going to try it just by making a table of values and knowing what we already know. So first of all, I have to know what my y-intercept is. My y-intercept, you have to be really, really careful here, right? My y-intercept is always going to be that value in front. Again, it's where the x value is 0. So looking at it, as long as there's nothing up here with the x, then my y-intercept in this case is going to be -3. So 0, -3. Okay? All right. Is it growth or decay? Okay. This number tells me that it's growth. Okay? However, what do you notice about the y-intercept? You guys know if we have a negative in front of the function, what's happening to the graph is it's getting flipped over the x-axis. It's getting reflected over the x-axis. So that negative that's in front is reflecting this for me. Okay? All right. So let's make a table of values for ourselves and use our xy's. Okay? So if we plug in -1 and 1, we plug in -1, we get -3